Hi guys, welcome back to the channel. So today we are going to be solving second bi-weekly contest question, which is minimum levels to gain the more points. We are given an binary nums of length n, and then we are also given two people, which is Daniel Chanji and then Bob, are playing the game consisting of n levels. Some of the levels in the game are impossible to clear. That means, suppose let's say if the possible of I equal to 0, then it is impossible to clear this particular level. And then let's say if the ith level is this then the ith level is impossible to clear for the both the players. And a player gains 1 point on clearing the level and loses the point if the player fails to clear it. At the start of the game, Daniel Chenji plays some levels in the given order starting from 0th level, after which Bob will play the rest of the levels. Daniel Chenji wants to know the minimum number of levels he should play to gain more points than the Bob. If both players play optimally, maximizing their points, return the minimum number of levels Daniel Chenji should play to gain points. If not possible, then return -1. So let us try to reframe this particular question. Suppose if we are given this particular possible answer. So if possible of possible of I equal to 0, then it is impossible to clear. If possible of equal to 1, then it is possible to clear. So this is going to be our array, which is going to give us whether it is possible to clear this particular level or whether it is possible to not clear this particular level. So now we are going to use, suppose instead of taking Daniel Chenji, we are going to take it as Alice and then Bob. So now allies want to get more points than the Bob. So the score of allies should be greater than Bob. That means this ally should have more points than the Bob. So now the ally should pick the possible array from the starting, and then till it should go till some at then point, and then he needs to get more points from this particular array, and then the Bob should get less points, and then we need to return the minimum allies should play to get more points than Bob. So this is what the our condition should be. Minimum levels ally should play so that we can get more points than the Bob. So we are going to start from here, and then we are going to pick this element, and then we are going to calculate the score. Or we can consider in the reverse order. Suppose if I pick this particular thing for the Bob, then whatever the whatever the score is obtained from the starting till here, it is going to be the score of the allies. And then if the score is greater than this Bob, then we are going to maintain the global variable where it is going to store the minimum number of levels allies should play, and then we are going to return this particular answer. So let us go through the code. So here we are going to say the total number of zeros, and then total ones, and then current zeros, and then current ones. Now we are going to calculate the total number of zeros which are present in this particular array. And then after calculating this particular total number of zeros, then we are going to get the total number of ones, which is going to be possible dot size total zeros. And then we are going to have the Bob points and then ls points, and then we are going to have the answer equal to int maximum. Suppose let's say at last, whenever answer equal to int maximum, that means we do not have any number of whatever the number of levels the allies place, he will get always less than the Bob. So that is going to be this corner state. So we are going to return this particular -1 for that particular case. If it is not equal to int maximum, then we are going to return this particular answer. And then we are going to start from the end of the array, and then we'll reach till I greater than or equal to 1. As it is given that we should have non each player must play at least one level. That's why we are going to consider I is greater than or equal to 1, so that allies will play at least one level. So suppose, let's say, if possible, of I equal to 0, then we are going to increment the current zeros, else we are going to increment the current ones. Suppose, let's say, the current zeros traveled by the bob is like this: 1 1 and then zeros, 0 and then 1 and then 1. Then whenever the bob had traveled 1, then he is going to gain 1 point. Whenever he travels 0, then he is going to lose 1 point. So that is how we are going to consider. Then the answer should be like number of ones minus number of zeros. So that should be the bob points. So the number of current ones and then current zeros is going to be the points of the bob. And then allies points is going to be total number of ones, which is total ones minus current ones is going to be allies ones, and then total zeros minus current zeros is going to be allies zeros. So these are the ones and then zeros consumed by allies in the previous state. And then we are going to consider the points as allies ones and then minus allies zeros. So this is what the allies points and then bob points. Whenever, let's say, allies points is greater than the bob points, then we are going to consider this particular level. Suppose, let's say, we are going to stop here. At this particular point, we are going to consider this particular I, so that he will allies will travel only 0 and then 1, which is going to be at least two levels he will travel. So we are going to consider answer equal to answer comma min. So for this, if we come to the time and space complexity, the time complexity is going to be big of n, and then space complexity is going to be big of n. Why? Because we are not considering any extra space for this. Yeah, that's all for this video. Thanks.